Assalamu alaikum. Today we'll present our project titled Simulation of School Dismissal Congestion in Jeddah. Today's agenda consists of the introduction, problem statement, project objectives, background information, current and proposed system, result and recommendation, verification and validation, and finally conclusion and reference. Traffic congestion around school during dismissal time is a common problem, especially when many school cars arrive at the same time for student pickup. This leads to long queues, delays, and inefficient traffic movement near the school gate. To study this issue, we use discrete event simulation through Simu software to analyze the current traffic system and evaluate possible improvements. Our project mainly focuses on the 87th secondary school in Jeddah, where we analyzed the school car movements during dismissal periods and proposed an improved traffic configuration to reduce congestion and improve the overall traffic flow. Moving on to the problem description. The main issue in this project is the traffic congestion that happens during school dismissal time. At the end of the school day, a large number of parents arrive at the same time to pick up students. Since all school cars move toward the same gate area, long queues start forming and cars spend a lot of time waiting before reaching the pickup point. This causes slow traffic movement and makes the whole area crowded and inefficient. Therefore, improving the traffic system can help organize car movement in a smoother and a more efficient way. In the current traffic flow, public cars continue toward the opposite exit route without entering the school pickup area, while parent cars proceed toward the school gate. However, despite this traffic organization, congestion still occurs because of the high number of arriving cars and the limited pickup capacity. As a result, queues begin to accumulate near the school gate and nearby intersections. The impact of the problem on the system becomes very noticeable now. High car arrival rate and limited pickup capacity create a queue accumulation near the school gate and intersection, negatively affecting traffic efficiency and increasing car delays. Moving on to the main objectives of this project. The first objective is to evaluate the current school dismissal traffic system during discrete event simulation. Second, to reduce car waiting times and queue accumulation near the school gate. And finally, to improve the traffic flow efficiency by implementing alternative traffic configuration. Regarding the background information, this study focuses on the 87th secondary school located in Al Ruwais district in Jeddah. During dismissal periods, around 260 students depend on the parent pickup school cars, which creates significant congestion near the school gate. The main roads involved in the traffic movements are Al Jazeera Street and Al Najm Al Tariq, which acts as the primary access routes during dismissal time. Moving on to the current system.
Thank you, Haneen. And now Mujdan Al-Harbi, moving to the current system. Here we model the current traffic system surrounding the school during dismissal periods using Simu. School cars mainly enter through Al Jazeera Street and Al Najm Al Tariq Street. The current system uses only one path leading to the school gate, which creates congestion and long car queues during peak dismissal periods. The pickup area can only accommodate up to 4 cars at the same time, while additional cars wait in queues before entering the gate area. The figures on the right show the semi-logical model and the 3D representation of the current traffic system. Moving to the proposed system. In the proposed system, traffic flow was divided into 2 independent paths based on the entry street. Cars entering from Al Jazeera Street use one dedicated pickup gate, while cars entering from Al Najm Al Tariq Street use another separate gate. Each gate can serve up to 4 cars at the same time. This separation helps reduce queue accumulation, waiting times, and congestion near the school area. The figures show the improved Simu model and the updated 3D layout of the proposed system. Moving to the results and analysis. The simulation results showed significant improvement after applying the proposed traffic configuration. The average school car time in the system decreased from 53.33 minutes to 13.79 minutes. In addition, the average queue waiting time at the gate reduced from 49.67 to an average for both gates about 10.32 minutes in the improved system. Also, gate utilization decreased from 99.24% to an average for both gates 50.90%. Also, all 260 school cars successfully entered and exited the system in both systems. Moving to the verification and validation. To ensure the accuracy of the simulation model, verification and validation were performed. Model verification was conducted using simu animation inspection by monitoring car movement, routing behavior, queue formation, and gate operation step by step. Model validation was conducted using a structured walkthrough approach supported by field observation. The conceptual model and traffic behavior were reviewed with individuals familiar with the actual school dismissal system, including school staff, security, and regular drivers during school dismissal periods. In addition, the time plot patterns showed realistic congestion buildup and gradual traffic reduction, which matched the actual observed traffic conditions. Moving to conclusion and recommendations. In conclusion, the proposed dual-path traffic configuration successfully reduced congestion waiting times and queue accumulation during school dismissal periods. The results demonstrated that simulation modeling can effectively support traffic planning and congestion reduction near schools. It's recommended to implement the proposed configuration and consider additional traffic monitoring system in future studies to further improve traffic efficiency. This is our references, and thank you for listening.